Welcome back to Discovery Planet.
Astronomers have captured a rare, real-time view of a planetary cataclysm 11,000 light-years away. While monitoring a stable sun-like star called Gaia 20EHK, deep in the constellation Puppis, researchers watched its light suddenly flicker and plunge as a massive cloud of hot debris drifted in front of it. This was the smoking gun that told them two planets had smashed into each other. It's a highly rare look at the same kind of violent impact that created our own moon billions of years ago when a Mars-sized planet called Theia smashed into early Earth. An oddly flickering star. The discovery began when Anastasios Zanidakis, a doctoral candidate at the University of Washington, noticed the star behaving like nothing he had seen before. For years, Gaia 20EHK was a boring main sequence star with a flat, predictable light output. Starting in 2016, the star's brightness dipped briefly 3 times. Then, in 2021, the light levels became chaotic and erratic. The star's light output was nice and flat, but starting in 2016, it had these 3 dips in brightness. And then, right around 2021, it went completely bonkers, Zanidakis said. I can't emphasize enough that stars like our sun don't do that. So when we saw this one, we were like, hello? What's going on here? The researchers concluded the star itself wasn't responsible for the flickering. Rather, it was being eclipsed by a massive, spreading field of rock and dust. To confirm what was blocking the light, the team looked at the system through infrared telescopes. While the star's visible light was fading and flickering, its infrared signal was surging. 2 planets, head-on. The infrared light curve was the complete opposite of the visible light, Zanidakis explained. As the visible light began to flicker and dim, the infrared light spiked, which could mean that the material blocking the star is hot, so hot that it's glowing in the infrared. This heat signature, reaching roughly 900 Kelvin, 627 degrees Celsius, or 1,160 degrees Fahrenheit, suggests that the astronomers were witnessing a planetary collision. The early, smaller dips in brightness likely represented grazing impacts as 2 planets spiraled toward each other, coming increasingly closer with each orbit around a common center of mass. The massive spike in infrared marked the final, catastrophic head-on crash that pulverized the worlds into a cloud of glowing dust. While the study doesn't state the exact diameters of the 2 doomed worlds, researchers can estimate their scale by measuring the massive wake of hot wreckage they left behind. Based on the intensity of the infrared glow, the freshly generated debris has a mass roughly equal to that of Saturn's icy moon, Enceladus. However, this relatively small value only accounts for the dust fine enough to glow in the infrared. Because a collision typically only pulverizes a fraction of a planet's total bulk, the original colliding bodies were likely considerably larger. A reminder of our own origin story. This cosmic calamity feels like a déjà vu. Roughly 4.5 billion years ago, a Mars-sized object is thought to have slammed into the young Earth, ejecting the debris that eventually cooled and clumped together to form the Moon. The debris cloud around Gaia 20EHK is currently orbiting at about 1 astronomical unit, 93 million miles, from its star, the same distance Earth sits from the Sun. This makes it a perfect laboratory for studying how terrestrial planets and moons are born. It's incredible that various telescopes caught this impact in real time, Zanadakis said. There are only a few other planetary collisions of any kind on record, and none that bear so many similarities to the impact that created the Earth and Moon. Catching these moments is incredibly challenging because the orbits must be perfectly aligned with Earth's line of sight. However, as new technology comes online, these once-in-a-career finds may become more common. James Davenport, a UW assistant research professor and senior author of the study, noted that the team's success is the result of slow astronomy that plays out over a decade or even longer timelines. He believes that the upcoming Vera C. Rubin Observatory could detect 100 similar collisions over the next 10 years. How rare is the event that created the Earth and Moon? That question is fundamental to astrobiology, Davenport said. Right now, we don't know how common these dynamics are, but if we catch more of these collisions, we'll start to figure it out.